Hey everyone, in this tutorial we'll be adding some outlines to some Blender models and we'll be importing them into a Three.js scene. The goal is to obtain an outline element as seen in a few games such as Genshin Impact, and we will be recreating the same effect in a Three.js scene. I'm making this tutorial because I couldn't really find anything during my own process, and I'm hoping it's going to be useful for people who want to achieve the same effect. Please do keep in mind that this is not a beginner's Blender or Three.js tutorial, but I will try to explain things as simply as possible. Before we start adding any outlines to the meshes, let's go ahead and take a look at what's already in the scene. You might notice that we actually have a background, so we're not going to be looking into the void for the entire tutorial. In addition to that, I've actually added orbit controls as well, just so we can take a look at the model from different angles. And finally, there's an ambient light, just so we can see our model in case we needed any lighting. Alright, with that being said, let's go ahead and jump into our case study. We're going to be adding an outline to this Tanuki model that you see right here from my game of the year. I became a Tanuki, but I couldn't get rid of my alcoholic tendencies. Go ahead and check it out in the description below. And please do keep in mind that there's actually a few different ways to add outlines to your models in Three.js. And for the first method, we're going to be taking a look in Blender. Alright, now that we're in Blender, let's go ahead and talk about the first method. We're going to be adding an outline to our mesh in Blender, and then we'll be exporting the mesh as well as the outline to Three.js, so we can have a very similar looking object at the end of the day. And one thing to mention is that this outline method is not something I created. As always, I'll leave a link in the description below. Alright, first thing you want to do is go ahead and import the mesh that you want to add outline to. I have my Tanuki here. Go ahead and click on him. And the first thing you're going to do is we'll be adding a material. And this material will be the material for our outline. As you can see here, I already actually have Tanuki material, which is the base map for our character right here. Go ahead and hit the plus button to add a new material, and go ahead and click on new. Go ahead and rename this one to outline. And once you've done that, you're going to be opening another window with the shader editor viewport. I already have one here. Just open any window and find the shader editor. Once you've done that, make sure you are on the outline material, which we have here. And you're going to be deleting the principled BSDF. Go ahead and delete that. And now go ahead and click Shift and A inside the window. And that's going to open a search bar. Type in search. We're going to be adding an emission node. Within our emission node, you're going to notice that there is a color and strength. We're pretty much just worrying about the color for now. This color will be the color of your outline. I want a black outline for my character, so I'm going to go ahead and select black. And now you're going to hook up the output emission node to the surface material output. And once you've done that, that's all you're going to have to do for the material. I'm joking actually. You actually have to turn on the backface culling. So go ahead and look back at the materials properties and turn on the backface culling option. That should be everything we have to do for the material. The next thing we have to do is go ahead and reselect your Tanuki model. Under the properties tab, we're going to be going to modifier properties. Click on that, and you're going to see add modifiers here. Click on add modifier, and we're going to be selecting the solidify modifier. Once we've done that, open up the normal section of the solidify, and we're going to be checking the flip as well as high quality normals. And the next thing is in your materials, we're going to be choosing material offset of 1. Now that you've done that, you actually might already have noticed that your character has an outline, and that could be changed with thickness. From what I've noticed, for at least in my models, if you go into the positive direction, it's going to squish your guy inwards. It might look really weird. And if you go into the negative direction, it's going to create a larger outline. So in this case, my model is actually fairly small, so I can use a number like 0.001 maybe. Maybe that's too little, maybe 0.03. There, you can see an outline already forming, and maybe that's too small for me. So let's go ahead and make that 0.01. And we have a fairly decent outline at this point. And for your models, it may be different, so just play around with the thickness until you get something that you'd like. Now we're going to be exporting the model into a format that Three.js can use. In my case, I'll be using a GLTF, so I'm going to be going through that process. At the top left-hand corner, click on File, go to Export, and I'm going to be selecting GLTF. And once I found the correct folder, I will be selecting the GLTF embedded, just for this example. I'm including the selected object. Do make sure to select the object that you are exporting. The transform is Y is up. In this case, I'm going to be checking apply modifiers, UVs as well as normals. I don't really think we're using normals, but I'm just going to leave that on for now. And I do have Draco compression enabled on my loader, so I'll also be using compression in this case. The important thing is the materials is on export, and image is automatic. And once you've done that, let's go ahead and rename it. So in this case, I'll call this Tanuki outline, and it should do the GLTF part on its own. So I'm going to go ahead and click on export GLTF, and that should have exported the outline as a GLTF. Let's go ahead and jump back into Three.js and take a look at that. Once your file has been exported from Blender, we can go back into our Three.js code, and we'll be able to type up some code to load our new model with the outline. In this case, I already have a loader here. This is what I used previously to load the Tanuki model. I'm going to go ahead and just duplicate this, and instead of loading tanuki.base, I believe I called it Tanuki outline. So we're going to be using that. And do keep in mind, my loader is a GLTF loader, and it has a Draco loader attached to it, so we can load those compressed files. And last but not least, we are also going to be moving the model that we've loaded to the left a bit, just so we can compare the two. So that's going to be gltf.scene.position.z equals 2.5. And just remember to add it to the scene, or else we won't be able to see it. Go ahead and save this, and we're going to return back to our Three.js scene. Once we've loaded back into our scene, you can see that there's two different Tanukis here. One clearly has an outline on it, and the other one does not. If we look around, it seems like the outline is holding up at every single angle. So that's great. And you might notice some jagged lines here, and that's just because my scene doesn't have any anti-aliasing on it. And I'm pretty sure if you have anti-aliasing in your scene, the jagged lines here should be removed. And if not completely removed, they should be at least reduced. So that is the easiest way to get outlines in your scene in Three.js. However, there is a small issue, or actually a very large issue, and that is the actual file size of these two files. If we jump into our file explorer, we can actually take a look at how large these files are. They're honestly roughly 2,000 kilobytes each, and that's around 2 megabytes. And it really depends on your scene, but in my case, I didn't really have the luxury of having such large files, and we're going to be taking a look at a few solutions to this in the next section. To rectify the issue of large file sizes, we have to return back to our Blender environment, because most of these issues are coming from when we are exporting our actual file. If we open up the export settings by going to File, Export, GLTF, the first thing we have to change is our format has to be a GLB format, and the next thing is under geometry, we're going to be removing this export section under the materials. We're going to be selecting no export instead, and in this case, I believe if you remove a few of these, you'll probably have a smaller file size. However, I'm just going to leave them as is. And we're going to be calling this file Tanuki no export. And make sure your Tanuki is selected, or else you're not going to export anything, just because it might include I've selected objects. I'm going to go ahead and export it. And if we take a look at the file size right now, you're going to see that the new one is 62 kilobytes compared to the 2,000 kilobytes and so forth. So this is a very large reduction of file size. However, there is an issue, and we're going to be able to take a look at that once we jump into our Three.js code. So I'm going to jump back into our Three.js code. We've added a new file, and that would be the Tanuki no export.glb. Do keep in mind that the GLB format does work with our GLTF loader. So instead of Tanuki outline, I'm going to type in Tanuki no export, I believe, and .glb. And this time we're just going to move in the other direction so we'll be able to see it. Go ahead and save this, and we're going to jump back into our scene. Once we've loaded back into our scene, you can clearly see that which one is the one that we did not export any materials to, and that's the one on the right. Clearly, it's devoid of any color, so the issue of reducing the file size is that it does not come with any materials whatsoever, and this is when we're going to have to set these materials up in Three.js ourselves in order to get the correct colors. In order to get the correct textures, let's just go back and take a look at how this is really set up in Blender in the first place. All we have is our base color is actually attached to this JPEG right here, which is the map for our base color. And what we're going to do is, instead of exporting it with the file itself, or with the model rather, we're going to be implementing this material within Three.js itself. So let's go ahead and see how we do that. Now that we're in Three.js, we can go ahead and create our new material. And we're going to need to actually import this file. I've actually attached the file in the same directory as the other models, so we're going to be calling it from there. And do keep in mind, you will need to import the texture loader. However, I already have it imported, and I'll be using it here. So const, what are we calling this? Tanuki texture, I guess. Tanuki texture equals our texture loader dot load, and then the directory and where we placed it. So I'm just going to be copying this entire directory, just changing the end, and instead of using tanuki.export.glb, I'll be using the name of our actual file. In this case, it'd be tanuki bc.jpg. And of course, wrap this in quotes. So once we've done that, I can go ahead and do a few other things. You might notice that when you're actually doing this, your texture might be flipped. So usually you will set flip y equals false, and we want the textures to be correct. The colors need to be as accurate as possible to what we see in Blender. So in this case, we're going to be ensuring that the Tanuki texture dot encoding is actually set to sRGB. That should be good too now. And then finally, we have to actually create the material with this texture, and then we'll be applying that material to our actual model. And let's go ahead and create the Tanuki material. And in this case, we're going to be using a mesh basic material, just so we don't really need any lighting or anything with this. So go ahead and type in new 3.mesh basic material. And the only thing we have to put in the parameters is that the map is going to be our Tanuki texture. And now once we've created our Tanuki material, we just have to go through the entire scene and just set the material to the Tanuki material. And to do that, it's fairly easy. Just dltf.scene.traverse, and then I think we have to put in a parameter here. So our child object will then be it's hard to type. And once we've discovered our child object, we'll set the child material to our Tanuki material. And that should be it. Again, once we've added it, it should be over to the right. And yeah, that seems like it's about it. So we can go ahead and save this and return back to our Three.js scene. So go ahead and save it and return back to our scene. If you look back at our scene now, you could see that there are definitely 3 Tanukis, and one of them is not completely pitch black, and it has the color. And you might notice that these other 2 are a bit brighter. That just might be because of the ambient light, whereas this is the original color, which is not receiving any light whatsoever. So this would be the most accurate in the sense of color. And that is pretty much how to set up a lighter model in regards to weight. However, you might notice that there is definitely no outline on this character, and we're going to be tackling this 2 different methods. The first one will be the post-processing method, which will be the next section. And the one after that is going to be the method that I use to actually add outlines to the models in my own portfolio. So let's go ahead and take a look at the examples and take a look at how the post-processing outline effect works. Alright, another day, another section in our tutorial, and in this section we're going to be covering the outline pass with the post-processing stack in Three.js. So right now we are currently in the examples for Three.js. Go ahead and type outline into the search bar, and we'll be able to find the post-processing outline pass. And what you can see here in our example, pretty much whenever I'm mousing over an object, in this case I'm mousing over the floor, you'll be able to see that the mesh is very clearly highlighted. And if I switch over to, let's say, the torus, you can see that there's a very distinct outline around the torus. This color can be changed by changing the visible edge color. So if I go ahead and change this to, let's say, red, you'll be able to notice that the outline is now red and so forth. So let's go ahead and see how we can implement this into our own project. Go ahead and click the button in the bottom right-hand corner. All right, so once you've reached the GitHub page, we can take a look at how we can actually implement this. And pretty much all you're going to need to do is include the effect composer, have a render pass, and in addition to that, to actually get the outlines, we're going to need our outline pass as well. And there's one thing to take a note of when we're dealing with the outline pass, and that would be in the outline pass dot selected objects right here. Pretty much you will need to add a list of meshes that you want to have highlighted or outlined rather, and you need to place them into the selected objects section here. So let's go into VS Code and take a look at how this is implemented. Alright, now that we're back in VS Code, we can take a look at how we're going to be setting up this outline pass. And if you may recall in our previous loaders, I've always had this line commented out, the add outline object, and I'm passing it to gltf.scene. So what this function does, I'll just show it below. All it is taking the parameter that we're throwing in, and we're going to be pushing it into an objects to outline, which is a list of objects, and then we're going to be passing that list of objects to the outline pass as selected objects in order to highlight them. And in this case, let's just go ahead and uncomment this. And once we save it, we can return back to our Three.js scene. Alright, now that we've jumped back into our Three.js scene, you can very clearly see that the third Tanuki on the right hand side is the one affected by the outline pass. So if you want to add an outline to an object without actually modifying the mesh, I believe that the outline pass might be your best approach. However, for my own case, the outline pass has an intended effect that when it is hidden between other objects, you can actually see it. So in this case, if I go ahead and move the camera and hide the object between the other two tanukis, you can still slightly see the outlined object behind all the other objects. And let's say if, in my case, I had a very busy scene, I didn't really necessarily want to do this. So in the case where you want to, let's say, highlight an object and make it shown through a variety of different objects in case it's hidden, then this post-processing pass is definitely a great way to go. However, for my portfolio, the outline is not necessarily a functional element, it's just a visual element that brings the scene a bit more to life. And in my scene, I didn't necessarily want to continue forward with the post-processing pass. So in the next section, I'll be talking about how I implemented the outlines in my own scene and how I tried to keep the file sizes as small as possible. Now in this section, we're going to be jumping back into VS Code, and we're going to be taking a look at how we can actually create the outline material in Three.js and then apply it to the model instead of going through with the post-processing method. Ideally, we can try to keep the file size fairly small, and in this case, we can get the outline that we had before without relying on the post-processing stack. And in this case, right now, all of that I've added in the function is a small log, so we can take a look at what information is actually in our scene and how we can target specific materials to very specific meshes. And let's go ahead and jump back to our Three.js scene to see what's actually happening. So once I've jumped back into our Three.js scene, again, we are just logging the tanuki on the right-hand side. You can see that there's a group. Of course, that's the group that contains the actual child mesh. And then we have one mesh right here, which is called tanuki low. And this is the standard mesh that we had when we exported. Let's go ahead and jump back into our Blender scene. As you can see on the top right-hand corner, of course, we have tanuki low. That is the mesh that we've exported. And in order to actually get the outline, which is the solidify modifier, all we have to do is in our export options, we just have to click on a few different options. And mainly those are definitely include the selected object, arch transforms Y up. We have to make sure to apply modifiers. And in our materials, if we choose placeholder instead of no export, we should be able to see the option now. Do keep in mind this will create a larger file size, but it shouldn't be around like 2000 megabytes, or not 2000 megabytes, sorry, 2000 kilobytes, which is around 2 megabytes. So in this case, just remember that our current one with absolutely nothing is 32 kilobytes. Now, if we take a look at the file explorer, we can see that it is 64 kilobytes instead of the previous version. So it definitely has been increased, but it has not been increased to the amount that we had before. After we've properly exported it, Three.js reloaded itself with the updated model, and you can see how the console logs actually say different things now. In this case, we have two different meshes, two different groups. I think I might have selected the scene. Oh no, it's been there on its own. And under the tanuki low as the container for two other meshes, there's the original mesh, and then there's mesh underscore one. So from what I've noticed, mesh underscore one is usually the modifier that we've applied to it. And we'll be able to add a very specific, let's say, a mesh basic material of, let's say, a black color in this sense, and then we can apply it to mesh underscore one. That should give us our outline. So let's go ahead and jump back into VS Code and take a look at how we can do that. Alright, now that we're back in VS Code, all we have to do is we just have to make sure we apply the outline material to that new mesh with the underscore and the one beside it. So let's go ahead and start by creating a new material for our outline. So let's just call this outline material, and it's pretty much just going to be a new mesh basic material. And there's no specific map to this, we just need a color. So let's just use black in our case. You can use hex code if you want. I'm just going to type in black there. And the next thing we have to do is when we're traversing the scene, we just have to make sure to apply the material to the specific object. So let's just say if the child material or the child.name is equal to, I think it was mesh underscore one. If it's equal to that, then we can just apply the child.material equals the outline material, like so. And then otherwise, we can just apply the material. Of course, you could always just check if this is a mesh in the first place and so forth. But let's just make sure this works first. So again, just for the logic, we created a new outline material. It's not going to take any light. It's just going to use the color black for a black outline. And if we discover a mesh underscore one, which is in our case the modifier for the outline, we're just going to apply this specific outline material to that modifier. And then we should have our black outline. And then otherwise, just set the material as it always has been. So let's go ahead and save this and return back to Three.js. Finally, when we load into our scene now, you can see that the tanuki on the right-hand side has the exact same outline as the tanuki that we have on our left-hand side. And the only difference is that, of course, the base map is using the mesh standard material on the left-hand side, and we're using the mesh basic material on the right-hand side. And that's why the one on the left-hand side looks a bit brighter. That's just because we are using the ambient light, which is maybe a bit too bright for our scene. So aside from that difference, the two of these are very different in file sizes. One is roughly 2 kilobytes, or sorry, 2 megabytes, and the other one's, I believe, around 60 kilobytes or so. So definitely this is a more light way to get those outlines onto your models. And definitely if you have any different approach on how to make this better, or perhaps you took a different approach in your own portfolio or your own experience and so forth, please do leave them down in the comments. There's no dislikes anymore, so I actually am asking people to like this video if you found this tutorial good, just so we can help other people in the future. So again, thanks for watching everyone, and hope you have a good one. Later.